After making a mini CNC printer using few servos and a friendly arm board, I found it wasn't that complicated, so I decided to try to scale it up to a bigger version and try to make a 3D printer. I started with making a rough 3D design using Blender to be able to see up ahead how is it going to look like. The entire frame is based on some aluminum bars I could find in the hardware store here, and most of the components were salvaged from different equipments like scanners and some parts I had laying around. We can see here the X and Y axis that's controlling the movement of the base using stepper motors underneath them. And concerning the Z axis, at first I planned to use different heads, so for example to be able to change from CNC milling to 3D printing. And this is a simple design for the filament extruder without the heating head. The plastic filament is pressed between two rubber wheels, where one is mounted on a servo motor. During the build process, I end up deviating a lot from this design, either because of materials or tools limitations, or simply by finding simple ways to do things, or trying to get around some of the problems I encounter. I started by cutting the aluminum bars to the correct measurements, then connecting them together using some shelf corner brackets, screws and bolts and washers. The stainless steel rod will go into these two pieces, which will stay on the top of the rectangle frame and will carry the X and Y base. I wanted to try the nut and bolt mechanism to drive the sliding movement of the base, so I mounted the stepper motors pointing horizontally. Unfortunately, I couldn't make the rod to turn smoothly without zigzagging. The bipolar stepper motor is driven by a homemade H-bridge circuit. I will leave the Eagle schematic in the video description. I really wished I had a coupler that would probably solve the problem. So I end up using a timing belt that I could salvage from few scanners I have around, as well as their stepper motors and gears, and the driving circuits. For the X and Y base, I've used a plexiglass that I got from a broken LCD, which I cut into half and fixed it to a metallic tube that slides on the stainless steel rod, and that was a very bad way to do it. And this is the first test of one of the axes. And the test of the two axes together. And yes, that's pretty slow. I couldn't get them to go faster than that. With the two axes barely completed, I started working on the holder of the Z axis and added some reinforcement as it was not steady enough. And here how all together looks like at this stage.